Welcome to another math session. When a problem uses compass directions, it is defining the specific geometric boundaries of your calculation. To ensure you are fully prepared for your WAEC, NECO and JAMB exams, QandA Help provides these exact breakdowns. Let's look directly at WAEC 2026, question 38. This diagram plots our starting facts. Point Q sits 6 kilometers directly north of a central point P, while point R sits 8 kilometers directly to the east. Because due north and due east are perfectly perpendicular, they meet exactly at a 90-degree angle. By locking these lines together, we have formed a right-angled triangle. Converting directional text into a standard shape provides the specific measurements required for the calculation. Look at the path through point P. A very common mistake is to simply add the 6 kilometers and 8 kilometers together to get 14, but the problem specifies the bus takes a straight route from Q to R. The vehicle bypasses P entirely, traveling directly along the triangle's longest side, the hypotenuse. To find the length of a hypotenuse, we use Pythagorean theorem. We substitute our known sides into the equation, giving us 6 squared plus 8 squared, which expands to 36 plus 64. Adding those gives us 100. By taking the square root of 100, we find that the actual straight distance the bus travels is exactly 10 kilometers. Notice the number relationship here. A right-angled triangle with sides of 3, 4, and 5 is a standard geometric pattern. Multiplying those base numbers by 2 gives you our exact dimensions of 6, 8, and 10. Recognizing proportional patterns like this lets you confirm your math instantly and save valuable minutes for the rest of your paper. We now move to the second phase of the problem. We have our true distance of 10 kilometers and an average speed of 40 kilometers per hour. We plug these into our kinematics formula, where time equals distance divided by speed. We divide 10 kilometers by 40 kilometers per hour. The kilometer units cancel each other out, leaving us with a simplified answer of 1/4 of an hour. Look closely at our result compared to the exam options. We have a fraction of an hour, but all 4 possible answers are strictly measured in minutes. To resolve this, we must convert our unit. We multiply 1/4 of an hour by 60 minutes, giving us a final travel time of exactly 15 minutes. With the calculation complete and the units correctly aligned, we confidently select option A. Doing the math perfectly will still lead to the wrong option if you ignore the final unit conversion set by the examiner. Let's lock this logic into your muscle memory by applying these exact same steps to 3 quick variations. If a point is 3 kilometers north and 4 kilometers east, the direct distance is the square root of 3 squared plus 4 squared. That equals 5 kilometers. For a vehicle traveling 30 kilometers at 60 kilometers per hour, we divide 30 by 60. That leaves 1/2 of an hour, which easily converts to 30 minutes. Finally, consider perpendicular sides of 9 and 12 kilometers, with a vehicle speed of 60 kilometers per hour. Using our 3, 4, 5 multiplier, the distance is 15 kilometers. 15 divided by 60 gives 1/4 of an hour, or 15 minutes. While the numbers on the exam paper will change, the sequence of geometry and kinematics remains consistent. Here is your cheat sheet for this problem type. First, north and east directions form a right angle. Second, the straight root is the hypotenuse. Third, always match your final units to the options. Excellent work successfully navigating both geometry and kinematics in a single session. For comprehensive, step-by-step preparation covering WAEC, NECO, and JAMB, visit QandAHelp.com and be sure to subscribe to the channel. Mastering the deep logic of one complex question gives you the exact tools you need to dismantle dozens of variations on test day. Keep practicing.